So this is Matt Moment from GE Digital, and he'll be talking to you not about 11 factors, but 12.
Just wait till you see what number 7 is. This is your app. Actually, this is the architecture diagram of your app. This is your app. And since we're all dressed up, it looks like there's a bunch of architects in the room, right? Product management's going to come to you someday and say, this app needs to be in the cloud. We need to scale. And you're going to be like, since when did product management ever start making architecture decisions? Always. So let's put it in the cloud. This is your app in the cloud. Still the same app. So I'm here today to tell you how to safely move that app into the cloud using the 12 factors established by Adam Wiggins of Heroku. So you can end up with, instead of this, you end up with this. But actually, if you were here for the talk before, you'll probably get something like this, because microservices. My name is Matt Momont. As introduced, I'm from GE Digital. I'm a newly minted architect by title, but probably more developer by role. I have helped GE build the cloud platform where we deploy a bunch of legacy applications that we call microservices. And we're trying to help these teams learn how to move from this monolith, as mentioned before, this monolith architecture into a more microservices or cloud-friendly architecture. And today I'm going to tell you about 12 factors that you can use to help you do this safely. And I'm totally stealing these 12 factors, to be honest, from Adam Wiggins. Again, he's co-founder of Heroku. But I'm going to give you a scorecard that you can use. So I'd like you to ask yourself, what level is my app at? When you see the next to the 12 factors, I'm going to give you 1, 2, and 3 for each of them. And I want you to see how your application may rate on that system and hopefully give you some ideas on how you can get your app cloud ready or improve your app that's already in the cloud. So why 12 factors? Strange things happen in the cloud. Lots of explosions. Network explosions, server explosions, data center explosions. How many of you have built an app with a cloud infrastructure before? A couple brave souls. All right, for those of you who haven't done it, there's things happen in the cloud that you may not expect and you may have no control over. So you need to build your app to be a little more robust than usual. You don't get to control the infrastructure. And then again, these 12 factors will help you do this safely. So what level is your app? Let's start with the first factor, and the first factor is your code base. Where is your code base? This, believe it or not, is very important when you're moving to the cloud. How many of you are still emailing zips around of your source code with file names like final version 2 - version 15? I've worked on teams where this is the mode of operation. Most of us get to level 2, right? We have Subversion, maybe, Mercurial, Perforce, Git. We probably use, hopefully we're using more of a distributed system like Git. I'd recommend it if you haven't tried it yet. But when you get ready for the cloud and when you start to build this sort of, when you break up your monolith into microservices, or you're looking to make more of a system as opposed to just a monolith application, you're going to want to break your app into pieces, and maybe microservices are the pieces of your application. And each of these should live in its own source repo managed by its own team. And this is important because it's going to allow you to deploy each one of those independently. So even if you build your monolith in a microservice fashion, all in one repo, you still have to deploy that one repo at once, or you have to check it all out, and all of it's still being shipped up to the build server. So it's really important to break it up. But again, this comes with overhead. So pros and cons. How do you handle your dependencies? How many of you are downloading off of SourceForge or something and sticking it into /lib in your project directory? Worked on projects that have done that. That'd be level 1. Level 2, you use some sort of package manager, NPM, Maven, allows you to download from a central repository. Maybe even your build machine will use this at build time to pull in dependencies. At a big organization, I'd recommend using something like Artifactory or a proxy for your dependencies. And this is where a lot of teams get to level 2 again. Level 2 seems to be a common place for teams to get to. But as big organizations, you need a little G word, governance, around where artifacts are used in your organization. And a proxy like Artifactory will allow you to do this and help drive consistency across your organization. Next, how do you configure your application? I hope you're not doing number 1. But if you are, it is okay. There's level 2 and level 3. There's opportunity for you. So I've worked on teams, hard-coded passwords, hard-coded URLs in your code. I've seen if mode equals dev, if mode equals prod. We've all been there. Most teams, again, get to level 2. Maybe they start by first getting those hard-coded strings into a constant, and then get those constants out into an application properties file. That's great. But as you go to the cloud, you're going to be deploying to multiple different environments. And what you're going to find is all of a sudden your properties files grow linearly with the number of your environments, which is not a scalable solution. What big organizations, and this goes along with sort of a registry lookup, is actually you can make configuration as a service. So something like Zookeeper or Spring Cloud Config can help you do this. And basically what it does is it allows you to put your configuration, all those millions of manifest files, into a repo, a source control repo on their own, which can be protected for your operations team only to have access to, or certain admins, and they can know the passwords or the API keys. And then the service will read that repo and provide it to the application at deployment time. And sometimes you can even get to some of these. I think Spring Cloud Config allows you to do that at runtime. Is actually if you update your configuration, you won't even have to redeploy your application. It'll be sent when it subscribes to this configuration service. The runtime will be sent an update every time the configuration changes, and Spring will go re-look up that environment variable. Backing services. These are the services that your application uses, whether they're just a database or they could be a full-on weather API, they could be a catalog service, they could be a microservice. You may start with, and I think we all do this when we first start with our PHP application, right? We hardcode that MySQL string, that MySQL connection. Level 1. Level 2, again, config files, classic. Lots of teams get there. Even mature teams get to this point. But the real benefits you're going to find by going to the cloud is to use something where you get a service registry, where you can look them up at level 3, and you start looking up these backing services at runtime or at deployment time. And those can change dynamically without you, the application developer, knowing about the updates. You all do CI/CD, right? Hourly releases, daily deployments. No, but I hope you're not level 1. Please don't tell me level 1. I work on a team right now, actually, that's level 1, or help a team right now that's on level 1. And we're learning why developers should not be the only ones that can, why it shouldn't be built on a build machine, or built on your laptop and then shipped to production. I think it was mentioned repeatable and reliable. Wasn't that the term about your releases? Level 1 is not repeatable or reliable. Level 2, use build tools. Again, most people get here, so everyone's using Jenkins or Travis CI, right? Great. Number 3, I think, is the big difference between level 2 and level 3 on this one is just using the tool is great to build, to offload stuff you're doing on your laptop to a build tool. Great. You at least have a little consistency there. Number 3 comes around a matured deployment pipeline. And this is 100% automated, except for one step, which I'll recommend to you. There's one step I'd recommend not automating. But as a developer checks in, that should kick off a build. That should get promoted to a dev environment that QA automated tests can run on. Product owners can look at, approve, accept, return stories. And then maybe even get promoted, we tag it with the release, and then it's promoted to a staging environment or RC candidate environment. And at that point, I would not automate it to push directly to production once that one's ready, right? I would put another button. I'd have the commit be the one manual step, and then I have one other manual step, which would be the product owner gets to say, release this build now. And that would be the one step I would not automate. I think that's a good gate to still have in your organization. Some people will even let the customer be the gate and have like upgrade now button, but I'd still make that a manual step than surprising your user with a brand new update. The other thing on level 3 that level 2 teams may not be doing is storing the build artifacts. So again, I mentioned Artifactory, that's just because what we use at GE. But you have kind of a build, test, deploy pipeline, right? In between your build and deploy, a lot of teams will just take that artifact and pass it on through. A great step that a level 3 team will do is take that build artifact and store it in a repository. So now what happens is when this build goes out into production and then you do it again and put out another build, and it fails, there's a bug, oh my gosh, we gotta roll back. all you have to do is go to Artifactory and pull the already built artifact as opposed to rerunning your whole CI pipeline, because you've already tested this, you know it works, and you've had it in production, so you know it's safe. You just want to roll back, and that'll allow you to roll back a little bit faster. Processes. So if you're familiar with the Unix philosophy, the 12-factor app methodology encourages you to build small stateless processes that do one thing well. So level 1 apps may be still using maybe a container-based architecture where they have an app container-based architecture where they have a sticky session. They may also, in level 2, they may not rely on any data stored locally, but they still have a sticky session. Level 3 is once you get that session out of that state out of your application and out of your microservice and into a backing service that manages state. So it's something, for example, even with something like J2EE, where you do have a sticky session, you can actually offload that into a distributed cache. It's basically pluggable. So even doing something like that will allow you to be a little more cloud ready as opposed to having that in-memory session, which is you have to hit the same instance, right, for every request. This one's a little confusing for people coming from a sort of a J2EE container Tomcat background into the cloud, where it's like Node.js, all the things, right? I apologize, I probably looked like a Node.js fanboy right off the bat. When you have a Tomcat container, it's going to inject a web server for you, right, at runtime. The cloud doesn't encourage that. It expects your app to be self-contained and to include the web server with you. So something like Play or Node.js or Rails, where it includes Jetty or Node itself, that'll allow you to deploy your application as is with HTTP as a service included in it. Also, don't expect ports that you listen on to be available. So no hard-coding ports. What you want to do is you want to listen on a port and let the cloud provider route to that port for you. And don't expect to be listening. Don't make any socket connections on a port because you can't be guaranteed that port will be available or will be even bound to your application. Concurrency. So this means your app should be able to run and to scale horizontally, just like the Unix philosophy. A lot of this comes from the Unix philosophy. If you want to be able to scale these out horizontally, not so much throw more memory at it, you want to throw more servers at it. So level 1, maybe you have a couple calls that all need to go and wait on jobs to complete, right? And maybe they do happen sequentially, even worse. So maybe you use promises, right? You use promises, but you chain them all together because they happen to happen in a certain order. That might get you to level 2. But what gets you to level 3 is where you have the ability to architect your app in such a way that you can farm out these jobs into a distributed computation grid-like architecture. So that'll allow you to maybe for example, let's take a good example, maybe do some calculation on maybe run an analytic on a database. I work in gas turbines, so maybe we need to see how to look over the past year's worth of data and optimally run this gas turbine. Oops. We would take the initial request to optimize and then farm that out to a bunch of jobs as opposed to just going to the SQL database and saying, run this giant query, wait 5 minutes and return that. So there's a little difference there. Disposability. This is probably the biggest thing I see teams struggle with as you move to the cloud. How many of you know what the IP address of the server you are running your application are on right now? Anyone who knows the IP address? Come on, what port? There's some people out there who know what that is. You're not going to get that in the cloud. Because what happens is the cloud is constantly moving underneath you. The infrastructure is going to be very fluid. There's a really not famous, but there's a really good quote, maybe famous, by Joshua McKenty of Piston Cloud, and he goes, "It takes a family of 3 to raise a puppy, but it only takes a few cowboys to drive 10,000 cattle hundreds of miles, all while drinking whiskey." Your ops guys running the cloud are probably more like the cowboys drinking whiskey than the family of 3 maintaining a puppy. Your servers are not pets. They are cattle, and they're going to be treated as such. You will not know the name of your server. You will not know the IP address. You will not know the port. You probably won't know what operating system it's even running. It's probably using Docker for all you know. It doesn't matter. All right, this is a huge one. I think a lot of legacy applications struggle here because they have so many dependencies on what their application needs. Heck, even like having curl on the command line available, it might not be installed on that box. Maybe it's a Windows box. You don't know. So don't have expectations about what is going to be provided. This one is for those of us who want to influence up, who want to influence management. This is a really good one. Who want to influence management to make the right decision. And this is a big investment, but it has the best ROI from what I've seen, at least in practice. How many of you work at organizations where the developers have no clue how to run the application in production? You have an ops team that takes care of all of it, right? You maybe check it into a repo. Maybe it even builds automatically and just magically gets deployed, right? On some days set, last year they said, we're going to release on May 1st, 2016. Okay, you release it. And the developer has no clue. That's level one. I see that a lot. That one's still pretty common. Number two is a little better. It's a good step. This will actually accelerate a lot of your development time, but it's a substitute, maybe mocks, God forbid, or maybe a lightweight SQL database that runs in memory on the developer's machine. It's better. But number three, where you get identical environments is where you are going to see tremendous ROI on your investment. Because what this is going to allow you to do is find those bugs where you can say, it worked on my computer, right? You can find those right away as opposed to waiting until it's in production, which we all know is, 1,000 times as expensive as finding it in development. So this is expensive, but very worth it. And as an ex-developer, I appreciate the investment GE has made in making a dev production parity in our environment. Has made tremendous improvement for development pain. How do you log? If some of you are familiar with 12-factor app, you may think level one is actually the right thing to do. One is full of gaping security holes. But two, you should probably question your hiring decisions for whichever developer wrote that. Level two, write your log files to your web server. This is pretty common, right? You have a app.log, production.log, error.log. How do you go find those error messages? SSH into the box, right? Oh, speaking of box. I'm sure. Good timing. So you SSH into the box. You look, you maybe do like a grep. Oh my gosh, seriously? This is 2016, guys. Hopefully, you want to get to a point at level 3, and a lot of the cloud providers will give you this. And so if you do actually level 1, if you do system out.print, if you have a good cloud provider, they actually will record that for you. Because what they expect is for you to log to standard out. And it will be a stream that will be captured and will be centralized for you by a cloud provider. So what you want to do is hopefully use some logging framework that does log to standard out as opposed to system.out. But what you do want to do is write to standard out as opposed to writing to log files on your web server, because that's going to disappear, right? Because again, we talked about the infrastructure being fluid. It's going to disappear someday, probably very soon, and that log file is going to disappear with it. This one's a little confusing and not terribly useful, I guess, for a lot of developers when coming to the cloud. But basically, what it's saying is you're not going to have access to the SQL database in the cloud. Can't log in and run raw SQL. We literally, on one of the teams I've worked on, is we do actually log into the production SQL database and make changes directly to the table, like using SQL Developer. That happens. I've seen it. That's basically what this is saying is you're not going to have that kind of access when you move to the cloud for good reasons. I think I saw a lot of people cringe when I said that. Use the framework's tooling. Use some migration tooling that's built into your framework. Spring offers a lot of things. Rails offers the same thing. Django offers this. Use the tooling. Don't expect to have access to the database. And deploy that tooling along with your application. So it should be just part of the same application deployment. So any app that's run, any instance of the application, you can hit the /admin route, log in, and run these migration scripts as needed. All right, so that was 12. I hope you guys found some nugget in here that you may take back to your team. How ready are you guys for the cloud? Are your teams ready to move? All right. Again, my name is Matt Momot. I work at GE Digital, and thank you for your time. Any questions? Yeah, we got questions.
So, we have been using 12 factors for some time now.
Good.
And we are, the kind of discussion I'm having with the lines of business is, do we really need 12 factors, or can we compromise on 10 or 11? And which ones?
Oh, absolutely, yeah. I mean, there's definitely some that, yeah. I think some of the most important ones, if you care for, I've seen are that disposability one about treating your servers as cattle, not pets. If you take away anything from this talk, is once you get to that point and you can deploy on anything, that will improve your turnaround. They talk about cycle time. You've heard that a lot today. And cycle time will improve tremendously, and the ability to change. I think we had the evolutionary architecture talk in here this morning. And that disposability one is really key to having an architecture that can evolve. Other ones? Yeah.
Matt, we're using Zookeeper.
Okay, great. Yeah.
Awesome, except
Perfect.
Zookeeper itself is not cloud ready.
Yeah.
The ensemble needs to know the IP addresses of the other members of the
Sure.
ensemble, and therein is like, so any thoughts around what you've seen with bringing apps into the cloud with underlying infrastructure itself is not cloud ready?
So we do a lot of like the hybrid approach, right? Is that kind of where you're going with this one? And it's a struggle. It's kind of like that halfway state where you have your legs on, you're kind of straddling the cloud and on-premise or your own hybrid. And yeah, that one's tough. I honestly don't have a good answer for you, but good luck is all I can say. Someday you'll get there and it'll be a lot less painful. But I've worked on teams where we got to the cloud and it's great, and I've worked on teams where we haven't even thought about it and it's still painful.
Number 10, you talked about dev prod parity.
Yeah.
When you're talking about the cloud, does that necessitate that you're also doing your development in the cloud, or are there other options for that?
So you can use something, are you concerned? So the question was, if you're developing in the cloud, if you're putting production in the cloud, do you also develop in the cloud? And I'm assuming it's because you're worried about pushing your development environment into production, like publicly facing right away. Is that?
Well, we talked about how having parity between the development environment and the
Yeah.
production environment is important.
Yeah.
So if the destination or the target is the cloud,
Yes.
does that also mean that the only option is to develop in the cloud as well?
So so you can have something like a private cloud. Amazon allows you to make one that you can have that only allows access in your network, which is what we use at GE, and that works pretty well. It allows you to have that local development environment that can only be seen by your internal network with VPC. And then you can have the production one that mirrors that.
Does that simulate or experience enough of the kinds of problems that you're going to see?
Yeah, great, yeah, it's close. One of the big things we struggled with actually is the CDN. It's how our CDN cache stuff and got in front of our application because we don't use a CDN in development. And believe it or not, our CDN had a lot of problems, which headers it filtered out. We use CloudFront for our CDN. And we didn't have development CloudFront, and that was a painful experience. I think that one is more of the spirit versus the letter, right? You want to get as close to parity as possible. But I don't think you can, I wouldn't recommend having every developer push directly to a public-facing website just to test it out, make sure that, have 100 instances of your website out in production. That might be a little dangerous.
So, Chris, what we did about this, we had two different subscriptions.
Yeah.
We use Azure.
Okay.
So for production and dev,
Mm-hmm.
so all the experimentation happens in the dev, and you can
Sure.
deploy. That's only available for developers. Unfortunately, we also have access, my team also has access to the prod.
Mm-hmm.
So,
Unfortunately?
as you rightly said,
Unfortunately.
well, fortunate for me, but the operations don't like.
Well, of course, yeah.
They're like, okay, give it back to us,
Yeah.
give all your rights and everything.
Oh, yeah.
Well,
Yeah.
we win.
I wish there was a 13th step, which is culture, which is like the DevOps culture and that trust built between them, which is,
Right.
that's a great point. Any other questions? I think so. You good? All right. Thank you guys so much. Remember, servers are cattle, not pets.